In this video, we'll work an example similar to number 12 in the extra practice assignment for sections 11.7 to 12.5 to help prepare for the exam. So I'm not going to do the exact same example, but I'm going to do one that's very similar. So let's say I had a graph like this. The graph goes up. Oops, got to turn the pen on. Graph goes up, kind of a corner, and then it goes down for a while. Say it flattens out for a while, and then it goes up again. So something like that, right? And you know what, actually, let's say on this end, oh, okay, hold on. Let's say on this end, there's a hard stop at the end, not, this one kind of implies that the graph continues off to the left. So let's say that, here's, let me put some axes on this. Let's say we have a y-axis and an x-axis like that, okay? All right. And let's say there are some numbers. Let's say this is like, say, 2, 3, 4, and let's say this is 6. Okay. So, if the question is find the intervals in which the function is increasing, that just means identify the chunks of the graph where the graph moves up from left to right. So, I'm going to highlight this section because the graph moves up from left to right there. Okay. Here, the graph moves down from left to right, so it's decreasing. So I'm actually also going to label this as INCR, increasing, okay? And then here also, this chunk, the graph is increasing, okay? So, again, here, the graph is not really doing either. I'm trying to draw it totally flat. It's not perfect, but pretend it was totally flat, right? The graph is not increasing and it's not decreasing. It's not doing either. Here the graph is decreasing, so that's not what we want. I want the two that are highlighted right now. So this first chunk, if I think about the x-axis that this covers, and the arrow implies that one goes to the left, and the x-axis section that this one covers, what part of the domain is the graph increasing on? Well, then I can say that this interval is negative infinity to 2, and I never include the endpoints because at this corner, the graph on the right-hand side of the corner is decreasing. On the left-hand side of the corner, the graph is increasing. As you approach the corner, you're going up. When you leave the corner, you're going down. So at the individual point, at that corner, you're not really doing either. So that's why I'm not including it in the interval here, the parenthesis instead of a bracket for that too, right here. Okay. So over here, I have the interval 4 to 6. Oops, and I should not be including the endpoints. And then, depending on the format, I can put a comma between them, or I can put the union symbol between them, right? So really this should be like right here, and this should be like right here. And that's basically it. If the problem were different, and it asked for the interval on which the graph was decreasing, well, that would be 2 to 3. That's the interval where the graph decreases. If the question was different from that and asked where is the find the interval in which the graph is neither increasing nor decreasing, well, that would be 3 to 4. Okay? So that's basically the different variations on that example. The problem on the exam that is like this might ask for decreasing. It might ask, I don't think it's going to ask for neither. Like, it's not going to ask you for the interval 3 to 4, I don't think, but you might either need a 2-part interval for increasing in the case of this graph, or you might need a 1-part interval in the case of increasing for this graph. I will also point out that on a multiple choice test, if that's, a lot of the problems are going to be the multiple choice format, perhaps not all of them, but a lot of them are, just this interval will be a choice, which would be incorrect because that's not the entire chunk of the domain on which the graph is decreasing. And then this choice, just this interval here, might be an answer choice. That also would not be correct. Okay, and that's it.